Chapter 30, Moons and Rings. Section 30.1, The Earth's Moon. A body that orbits a larger body is called a satellite. In 1957, the Soviet Union launched Sputnik 1, the Earth's first artificial satellite. In 1958, the United States launched its first satellite, Explorer 1. A natural satellite, or any planet, is called a moon. The Earth's natural satellite and closest neighbor is referred to as the moon. If you were to visit the moon, you would immediately notice that the force of gravity of the moon differs from that of the Earth. An object's mass determines its gravitational force. Because the moon has less mass than the Earth does, its gravity is weaker. Its surface gravity is about 1/6 the surface gravity of the Earth. As a result, a person who weighs 600 newtons on the Earth would weigh about 100 newtons on the moon. As you may recall from Chapter 2, on the Earth's surface, 1 kilogram of mass weighs about 10 newtons. Between 1969 and 1972, the United States sent 6 Apollo spacecraft to the moon. The astronauts that landed on the moon found that the weak gravity affected the way they moved on the moon. Instead of walking, they bounced along in hops and leaps. The moon's gravity is not strong enough to hold gases, so the moon has no atmosphere. The moon's surface temperature ranges from 134 degrees Celsius during the day to a negative 170 degrees at night. Whoo-wee! That's a big change. Because the moon has no atmosphere to act as insulation, and because of its slow rotation, the moon's temperature variation is far greater than the Earth's. With respect to the background stars, the moon rotates once every 27.3 days. But a lunar day is 29.5 Earth days long because the moon is also traveling around the sun at the same time. The lunar surface. The moon is close enough to the Earth to be seen easily without a telescope. The next closest object to the Earth is Venus. At their closest approach, the distance between Venus and the Earth is more than 100 times the distance between the moon and the Earth. An observer on the Earth can see light and dark patches on the moon. The light areas are rough highlands composed of light-colored rock. The dark areas, called maria, are smooth and reflect little light. Mare is the Latin word for sea. Early astronomers thought that the dark areas they saw on the moon's surface were bodies of water. Today, astronomers know that the maria are plains of dark, solidified lava. These lava plains are the remains of ancient volcanic eruptions on the surface of the moon. Long, deep channels called rills run through the maria. A rill looks somewhat like a dry riverbed. However, the moon's rills were probably lava channels when the moon was volcanically active. Some rills are as much as 240 kilometers long. Craters. The surface of the moon is covered with bowl-shaped depressions called craters. Most of these were formed 4 billion years ago. At that time, the moon, like other bodies in the solar system, were bombarded with chunks of debris left over from the formation of the solar system. As this debris struck the moon, it pushed surface material up and out, forming craters. Debris that struck the moon in a more recent past had a similar effect to that of an object striking the surface of a pool or a lake. The displaced materials settled in streaks called rays that extended radially outward from the impact site. Some craters have diameters as large as 250 kilometers. The entire state of Connecticut could easily fit into some of the moon's craters. The largest craters are named for famous scholars and scientists, like Tycho and Copernicus. The lunar surface also has millions of smaller craters. Many of these craters overlap one another. Some smaller craters are located entirely within larger craters. Geologists suggest that the Earth once had many craters similar to moon craters. The Earth's craters have been almost completely eroded by the forces of water, wind, ice, and tectonic activity. Because the Moon lacks these erosional agents, its surface has changed little since it formed. Lunar rocks. Meteorites of all sizes struck the Moon. They crushed much of the rock on the surface into dust and small fragments. Today, almost all of the lunar surface is covered by a layer of this thick dust and rock. The material in this layer is called regolith. The depth of the regolith layer varies from 1 meter to 6 meters. The number of meteorites that reached the surface of the Moon was greater than the number that reached the Earth's surface. Why was this? Lunar rocks contain many of the same elements that occur in the Earth rocks, but in slightly different proportions. Near the lunar surface, igneous rocks, like those in the Earth's crust, are composed mainly of oxygen and silicon. Rocks from the lunar highlands are light-colored, coarse-grained rocks called anerythrocytes. These rocks are rich in calcium and aluminum. Rocks from the Maria are dark-colored, fine-grained basalts, which contain large amounts of titanium, magnesium, and iron. One type of rock found in both Mara and the highlands is breccia. Breccia contains fragments of other rocks that have melted together and were formed when meteorites struck the Moon. The force of the impact broke up rocks, and the heat from the impact melted the fragments together. Lunar rocks contain only small amounts of some elements commonly found in the rocks on Earth. For example, lunar rocks are deficient in elements with low melting points, such as sodium. These elements may have boiled off when the Moon was still molten. Also, the minerals in lunar rocks do not contain water. The surface rocks on the Moon are about as dense as those on the surface of the Earth. Yet the overall density of the Moon is only 3/5 the density of the Earth. The difference in overall density indicates that the interior of the Moon is less dense than the interior of the Earth. The interior of the Moon. Most of the information that astronomers have gathered about the interior of the Moon comes from seismographs. Those are the things that detect earthquakes. These instruments were placed on the Moon by the Apollo astronauts. Seismographs have recorded numerous weak quakes on the Moon, which are similar to earthquakes. I guess you could call it a moonquake. They have also revealed that on the side facing away from the Earth, it is up to about 100 kilometers thick. The surface on the far side is mountainous, with only a few small maria. The crust appears to consist of materials similar to that of the rocks in the highlands. Beneath the crust of the Moon is the mantle, which is made up of dense rock that is probably rich in silica, magnesium, and iron. The mantle reaches to a depth of about 1,000 kilometers. The lower portion of the mantle may be slightly molten. The Moon may even have a small iron core. Scientists estimate that the radius of the core is less than 700 kilometers. The Moon has almost no overall magnetic field, although there are small areas of local magnetism, suggesting that the core is probably solid. Development of the Moon. The study of moon rocks and data gathered by astronauts has provided evidence to help astronomers understand the history of the Moon. Astronomers generally support the giant impact hypothesis about the first stage of its origin. This hypothesis suggests that the Moon formed when a Mars-sized body struck the Earth early in the history of the solar system. This collision caused an ejection of fragments into orbit around the Earth. These fragments eventually joined silica-rich mantles of the Earth and the colliding body, while dense metallic core materials remained in the Earth. The hypothesis is supported by the silica-rich samples of moon rocks brought back by Apollo astronauts. Scientists generally agree that the subsequent stages of the development of the Moon. In the second stage of development, the surface of the Moon was covered by an ocean of hot molten rock. In time, the minerals in the molten rock separated. The densest materials moved to the center and formed a small core. The least dense materials formed an outer layer. Materials of intermediate density settled between the core and the outer layer, forming the mantle. The third stage in the development of the Moon began as the outer surface of the moon cooled, forming a thick, solid crust over the molten rock. At this time, many pieces of the debris left over from the formation of the solar system struck the moon, producing its cratered surface. Some of the meteorites that hit the moon broke through the crust. Molten rock from beneath the crust flowed to the surface and partially filled the craters, forming the smooth maria. Sometime before 3 billion years ago, the number of loose particles in the solar system decreased. Therefore, less material hit the lunar surface, and cratering decreased. During this most recent stage of lunar development, virtually all geologic activity stopped because of cooling. Rayed craters were formed by the most recent meteor impacts. The moon today looks almost exactly as it did 3 billion years ago. Therefore, the moon is a valuable source of information about the conditions that existed in the solar system a long time ago.